Hello guys, welcome back. My name is Arpit Shah and today I'm going to talk about anonymous inner classes in Java. So what is anonymous inner class? Anonymous is something which is not identified by its name. An inner class, as name suggests, it is the class which is inside some other class. If you understand prerequisite concepts, then this tutorial will be easy for you to understand. Those prerequisites are classes and objects and how to instantiate them, inheritance in Java, basically use of keyword extents, interface in Java and how to implement them, and method overriding. If you don't know these concepts, then you can look at my other videos to understand them properly. I would be giving quick overview about these concepts during tutorial, but it won't be in detail. So let's get started with an example. Let's say customer has given us a task that please implement a program which can mimic different brand mobile phones available in the current market. So to achieve that task, I'm going to implement a couple of classes. One will be a common mobile phone class which would have implementation of all generic features available in each mobile. And then another class would be unique per brand. So I'm picking Samsung for an example, and that would only implement features that are unique to Samsung. So let's start with the common class first. So let's create a common phone class and I'm going to name it phone generic. And let's implement a couple of common methods. So one method is maybe print brand name, and that method will print generic because at this point we don't know what is the brand name. And another method will be, let's say, print features, and each mobile would allow you to call, so I'm just printing calling at this point. So these will be our common class which has all the generic method implementation. Let's create a class for Samsung brand, so let's call it Samsung. And Samsung will extend our generic class because we do want all of those common method as inheritance, and so Samsung class can make use of them. But Samsung do not want to print brand name as a generic, so we need to override that method. So what I'm going to do is override these print brand name method and instead print Samsung as brand name. So whenever we override the method, it would be always good idea to put this tag override. So what is happening here is we are using phone generic class as our parent class, and because Samsung class is extending it, it will get all the parent class method in inheritance, and we are overriding one of those method with our own implementation for Samsung mobile. So instead of printing generic, it will print Samsung instead. So let's try and create instance of that class to understand how it works. So let's create Samsung object, and if we exercise this object, we can print brand name and we can print feature list. And if I execute this code, you will see that it's printing Samsung as a brand name and it is printing calling, which is implemented in our parent class. So everything is working as expected. Now let's think for a minute what we are trying to achieve here with the Samsung class. So we had a class phone generic which holds all the generic method implementation, and we wanted to override one of that method so that we can print Samsung instead of generic. So the whole idea of creating Samsung class was to just override some of the method that we wanted it to behave differently. Now, is there any alternate way in Java which could be more efficient? So yes, Java does have an alternate way which could achieve the exact same thing, and it will be more efficient in terms of writing a code. So let me show you how that works. So in main class, originally we created object of Samsung, but let me delete this code so I can show you the alternate way. So what we can do instead, don't create this class called Samsung, but instead use the generic class only and create object of that class. So I'm going to name the object Samsung, and if I put a semicolon at the end, generally we know that these line would create an object of phone generic class. But in this alternate method, you don't put semicolon here. You instead provide a curly braces and put semicolon right at the end. What these will allow us to do, it would allow us to provide the override method implementation within those curly braces. So we wanted to override this print brand name method. We can copy that and change the print line to Samsung, let's say. So we did not create a separate class called Samsung, but instead we created an object of the generic class and then provided the overridden method within the same instance. Now if I exercise this object and print brand name, you will see that it behaves exactly same way as how we done using Samsung class. As we can see, the both approach achieved the same end result. Then what is the right way to implement the code and why one method is better than the other? So to understand all that, let's try and understand the difference between them. If we look at the compile classes, which are generally stored in a bin directory of the project, you would notice that compiler creates this file with extension .class for every class that we create. So main class has a main.class, phone generic has phone generic.class, and Samsung has Samsung.generic class. So that is our first approach, that every time we wanted to override the method, we create the class and then use the object of the class to do our action. When we use the alternate method, we did not create a separate class, but instead we created object of a first class, which is phone generic, and then we implemented all the method which needed overriding within the same implementation. So what compiler do in this case, it will still treat that as a separate class, but because we never provided the name for that class, it would create like main with the $1.class. So for compiler point of view, it is still treated as a separate class, but from the coder point of view, you did not have to create a separate class, and the number of line of code you had to write was also significantly reduced. Now, if from a compiler point of view, the both implementations are treated very similarly, then what advantage does it give us? So the advantage of using these second alternate way is that user don't have to create a separate class and the number of line they have to write is reduced. Also, the implementation is visible within the same class where you are writing the code. So sometimes it's easy for user to understand what is actually happening without jumping between classes. Apart from that, there is a disadvantage of using this implementation because you never created a separate class. You can't create a second object of this implementation, so you can't reuse this class. But if you would have gone with this original approach where you created a Samsung class, you can keep creating these Samsung object and keep doing different things with it. So the second approach we have used is called anonymous inner class approach. Now, why do we call it anonymous inner class? Because as I showed you, the compiler still treats this implementation as a separate class implementation. So we still have to call it class. We never provided name to that class. So the name of the class is anonymous. And this class is residing inside our main class. So it is definitely an inner class. So that's why the name of this implementation is called anonymous inner class. So now you guys understand what is anonymous inner class. Let me explain to you how many different ways anonymous inner classes can be used. So the current example showed you how to use anonymous inner class in inheritance scope. So basically, instead of creating a class which inherits other class and then overrides the method, we overridden method using anonymous inner class. You can also use anonymous inner class for interfaces. So let me show you how that can work. So let's create an interface. Let's call it phone generic 1 because we already have a class named phone generic. So I just named it phone generic 1 just to differentiate. And in this interface, because interface does not provide method implementation, it will just provide method signature. So let's create a method print brand name, and let's call print features. So I'm keeping the example same, so I don't have to change anything. So in this interface, we are saying whoever implements this interface, they must provide these two method implementation. So let me show you how we can use that using our anonymous inner class concept. So let's go back to our main class. Let me delete the original example. So as we have seen in previous example, let us start by writing skeleton for inner class. In this example, we want to use interface. So I'm just going to use interface, which is phone generic 1, and provide the name for the object, which is Samsung. Then initialize this new class. Now, there are few things that confuses most of the people. So if you look at this line, it may make you feel like you are creating an object of an interface, but in reality that's not possible. So what is happening here? So as I previously explained, that compiler would still treat anonymous inner class as a separate class. So compiler would in the background create anonymous inner class, and then that object will be assigned a name Samsung. So the Samsung is an object of the class which compiler creates and not the object of the interface. So it's a very important thing to understand so you don't confuse yourself. Now we also know that according to interface contract, whichever class implements this interface has to provide method implementation which are listed in the interface. So in our case, we have listed two methods. So the class that we have written must provide the implementation, and that's why Eclipse has created two skeleton methods for us. So now we can write implementations inside. So available features will be calling just to keep it aligned with our previous example, and brand name would be Samsung. So if I execute this object, so Samsung dot print brand name, you would see that it will print Samsung, and it's doing it as expected. So there you go guys, now you understand how to use anonymous inner class in interface scope. Let me take you through some of the examples that you may have come across in the usage of Java. So if you have ever created a thread, you may have used the class called thread class. So thread class is an example of how to implement anonymous inner class to override the method. So when you create a thread object, when you implement this run method, you are essentially overriding the run method provided inside the thread class. The same way, you may have also come across this example of runnable class. So that is an example of how to use anonymous inner class with an interface. In this case, when you are creating object R, you are implementing runnable interface, and that's why you'll be forced to provide implementation of the run method. If I summarize what we have learned so far, then we now know how to implement anonymous inner classes. The advantage of using them is that they are quick to implement. They are providing visibility to user because they are all written in the same class, and it also saves user from creating separate classes for the code which may be just one of use. Disadvantage is that the object instance is one-off. You cannot reuse that object, or you cannot reuse that code for any other purpose. So if you would like to reuse the code, you should stick to the first method where you create a separate class and use the object of that class. So that is it about anonymous inner class. I will be posting more videos as time permits. So if you would like to keep yourself up to date, please do not forget to subscribe. Thank you for your time, and I will see you next time.